Saxon Algebra 1, Lesson 54. This is a very exciting day, student, in your algebra life. I'm very excited to introduce to you one of the main topics of algebra that we're going to come back to again and again and again and again and again. You're going to be doing this for years to come, and most students develop quite a fondness for this process that we're going to do. It's called substitution. And before we get into it, I'm going to use a bunch of words and confusing phrases to express an incredibly simple idea. Okay, I'm going to write some things down and then I'll tell you what it means. Just making that scratching noise of my pen. This is so simple. I know I'm making it sound really, really complicated and you're copying all this. Remember, copy everything I write down. But I'll explain to you what it means and why it's important in just a second. Okay, there it is. It's a big theoretical puffy cloud of knowledge. I'll give you a minute to finish up, and then I'll tell you what this actually means. If A and B are equivalent expressions, that means if they're equal to each other, then A can be substituted for B and B can be substituted for A. If we say two things are the same, we can interchange them in equations and it's perfectly fine. That's what that means. When we start to do it, you'll see, oh, this is super logical. This is theoretical, this is hard to understand, but I just want to put these words down on the page so that when we come across it, you'll go, oh, that's the theoretical thing she was talking about. Now I see. All right, why would we need substitution? Well, let me show you. I'll start down here, even though there isn't much room. This is our first example, and what John has written out for us is a problem that looks like this. Okay, copy all of that. This is what's known as a system of equations. Oh boy, we're going to talk about that for a long time. How can I tell it's a system of equations? Because they have the same letter. There are two different letters involved, and each equation has the same two letters, and there's this bracket thing in front of it. Oh boy, this is what really tells me. This little bracket thing makes it very clear. What we're saying is find a value for x and a value for y that can make both of these equations come true. Okay? I don't even want to write all that down, but that's what a system of equations means, is find a value for each letter that will make both of these come true. So we have to figure out how to do that. What I'm going to do is I'm going to recopy these equations to the top of the next page. You can keep going if you're there, and I want to show you something really cool about them. Let's see, it's 2x minus y equals 1, and then x equals minus 3y plus 11. Okay, that's our system of equations. Now, let's look at something that's really cool. This one has an x and a y in it. This one has an x and a y in it, but notice that the x is all by itself. We've been given an equation where we're told this is equal to x, but we also have an x right here. So what would happen if we took this information and said, okay, this is equal to x, we can put it in the place of that x as well, because if it's equal to this x, then it's equal to that x, because we're all in the same system. That's the substituting that I talked about. If this is an equivalent expression to x, then we can substitute this equivalent expression, if you will, in for that x as well. What does that look like? First, I take this expression and I write it with a bucket in the place of the x, because that's where I want to do the substituting, right? I want to change that x to say this. So now I've created a hole where this expression is going to go in, and I pour it into this hole. So this will become minus 3y plus 11. Do you see how we did that? We just substituted the second equation into the first equation. We could do top to bottom, we could do bottom to top. The important thing is that we have one equation that is equal to a single letter. And that creates an expression that we can easily pour into that. Now I had to be careful because we have to multiply that by 2, don't we? We'll get to that in a minute. But I want you to see how the substitution is directly between the two letters. Right? We couldn't substitute this one into this one because it's not set up properly. We would need to have one letter by itself. This is what makes it possible to substitute. It's having one letter by itself on one side of the equal sign. All right, so we have substituted this in. Now we solve, and you're really good already at doing that. So what we'll do is we'll distribute. So we'll get minus 6y plus 22 minus y equals 1. We can combine these like terms. At the same time, we'll swim this minus 22 over here. That cancels. Minus 6y minus y would give us minus 7y, and this will be minus 21, right? Doing this kind of algebra is familiar to you. Divide both sides by minus 7, and we get y equals positive 3, right? Yay! We figured out what y is in this set of equations. Now we have to go back and figure out what x is. We have to get both answers in order to be happily completed, all right? So that's one thing that's slightly annoying about these substitution, these system of equation problems, is that you do a whole bunch of work and you finish and then you realize, oh, I'm not quite done. So then what we do is we choose either one of these original equations and we plug this value in. Again, that's a calculation you're familiar with. I like this one. It looks easier to me. You'll soon get the hang of which ones are easier. And so we'll say x equals minus 3, and now we can substitute that value in, okay? X equals minus 9 plus 11, x equals 2, right? Now, we can box these and call them the answer, but I'm going to blow your mind just a little bit more. The best way to write this answer is as an ordered pair, x and y, like so. X is 2, y is 3. Because the reality is, we could graph both of these original equations. We could rearrange them into y equals mx plus b. We could graph them, and this represents the place where, let's say we graph them on here, right? Let's say they went like that. This point is the place where they intersect. Now, obviously, I haven't drawn this properly because that is not point 2, 3. But just imagine that I did draw it properly. This answer, the values for x and y that we get when we solve the system of equations by substitution, that represents the point where the two lines intersect. That's kind of a crazy idea. Okay, and that's why I always like you to write your answer as an ordered pair, is to remind yourself, I know that you're reminding yourself that this isn't just an arbitrary value for x and y, this is a point, and it's the place where these two lines, because these do represent lines, it's the place where they intersect. Holy cow, what an amazing idea, right? We're going to solve systems of equations for a long time. Substitution is one way to do it, right? It's the first way that we're learning. We will learn other ways later. You don't have to worry about that right now. I just want you to know that there are other ways. They will do the same thing. They will take two lines and they will help us find the place, the point where they intersect. We just will use different strategies. Okay, let's practice. We're going to do a total of 5 of these. Woohoo! We're going to be so good at this. Ready? 54-2. Use substitution to solve for x and y. Here we go. Okay, this is the important feature that tells us it's a system. We notice the x and the y in both equations. That's cool. That's what we expect. They're not arranged in y equals mx plus b format. That's okay. They don't need to be. We are not going to graph these, so we don't care if they're in that slope-intercept format. It's perfectly fine that they're scrambled in different ways. That doesn't bother us at all. But we recognize that if we wanted to, we could rearrange these into y equals mx plus b and we could graph them, okay? We just want to remember that's an option. What we're looking for now is a way to substitute one equation into the other, and we zero right in on this. It's a letter, it's a letter by itself on one side of an equal sign, all set and ready for us to plug in. Later, John is not going to make it so easy. We're going to have to do some work to set one up like this. But right now, he's being nice to us, and he's saying, look, here's one letter equal to the other letter and, some number thrown in. And so we just look for the same letter in the other equation, and we go, okay, that's what we're going to do. We're going to recognize that those two are the same letter, and we're going to put x minus 6 in there because we know that's equal to y. So I copy the other equation and I create a hole where the variable goes where we're going to be doing the substituting. But I finish writing the first equation first so that I don't mess it up. 2x plus 3y, there's the new y, equals minus 13. Now I'm ready to substitute, which I imagine as picking up a beaker and pouring it in here. We pour in the x minus 6. And now we have some algebra to do. We're distributing minus 18. Okay, that's just simple distribution. There's nothing fancy about that. And now let's see, we'll add the like terms and then we'll add 18. We'll swim the 18 over to the side, the plain number fish. This cancels. This becomes 5x. Minus 13 plus 18 is positive 5. Oh, John, these numbers almost always come out cute and easy. What I like to do, because I don't want to box this, because I know I'm not going to write my answer in this form. I'm going to write it as an ordered pair, but it's important. So I squiggle it. That helps my eye find it when I want to actually write my answer. My final answer. All right, so now we have to solve for y. And I will say this, sometimes you solve for x first, sometimes you solve for y first. It's all a question of which variable you're given by itself. It doesn't matter. We just have to keep it straight, which is which. Okay, so I can use this same expression. It's going to be great. Y equals x, which is 1 minus 6. So y equals minus 5, right? That's just straightforward algebra. And so now we write our answer as an ordered pair. Here, I'll put the squiggle under that too. It's going to be 1 minus 5. That's the correct answer. Again, if we wanted to, we could graph both of these lines, and this would be the point where they intersect. We'll do that later, but we're not doing it now. Now we're just focusing on the algebra. Another. That's my chair. It's very squeaky. I stand up to make sure my book is back in frame when I flip the page, and my chair just protests, doesn't it? 54.3. Use substitution to solve for x and y. The instructions are always the same. Okay, so again, we look through our equations and try to see if there's one where one letter is by itself on one side of the equal sign. There it is. In all three of these examples we've looked at so far, the equation with the single letter has been on the bottom. It doesn't have to be on the bottom, and it isn't always going to be on the bottom. John's just giving it to us that way for whatever reason. But it doesn't matter which letter it is, and it doesn't matter if it's on the top or the bottom, as long as we identify, oh look, that letter matches to this letter here, and we can substitute that into it. I like to kind of draw this on here to remind myself of what I'm doing. Those are both x's. They're equivalent expressions, so we can substitute this, which is equivalent to that one. We can substitute that in there. So I take the equation that will be substituted into, right? This is the one I'm substituting in. I'm pouring it into that. And I write it with a big gap where I want to substitute in. Many, many mistakes are made because in the copying, students get confused and they scramble together the equations. So write the whole thing out. Make sure it looks just like this, only there's a bucket where the matching letter goes. Now you can pour this in. 3y minus 10. And notice when we do this, what happens is we get rid of this letter, and now we just have y's, which is great because we can solve for y if that's the only letter in the equation, right? There's no x's in here to trip us up. All right. Again, we're going to distribute. This is almost always how these problems go. The algebra stays the same. 9y minus 30 plus 2y equals 3. All right. We'll add the 30, swim the plain numbers over here, and then we'll combine the like terms. We'll do that all in one step. 9y plus 2y is 11y. This cancels. 3 plus 30, 33. These problems almost always come out with precious little answers. And they're very satisfying. Later we'll get into a specific type of these that sometimes has decimals. But right now, John just gives us cute little integers all day long. And I love him for it. All right, so we've got our y value. Pick an equation. Either one will work. It's just a question of which one we think looks easier. And I like that this x is all by itself, so I can write x equals 3 times y, which we decided is 3, minus 10. X equals 9 minus 10. X equals minus 1 is what that's looking like to me. There's my second one, so I write it as an ordered pair. X comes first, minus 1. Oops. Oh, I was trying to write a 10. Minus 1, 3. My brain got all excited by seeing those and I wanted to write a 10. But no, it's just minus 1, positive 3. That's the right answer. Are you starting to feel like you get it a little bit? Chair. Okay, 54.4. Slight twist. ever so slight twist. Here's our system. We look at our problems, and at first, when I look at, let me use this. When I look at the top one, I panic for a second because I think, oh, this x needs to be by itself and it needs to not be a minus, and I can't substitute it the way it is. Oh no, what am I going to do? I panic a little bit when I see that plain letter. But when I look at the bottom one, I go, oh, here's another plain letter that is the way I want it to be. No minus sign equals to everything else. This is the one I'll substitute here. It's okay if this is kind of a mess because that's going to be what we call the base equation. This will be what we substitute in. This will be, I sometimes put an asterisk here. We can call that the base equation, all right? That's the one we're substituting into. So I'm not going to let that freak me out. This looks perfectly lovely, and I'm going to put it in here, aren't I? And this is the expression that I'll pour in. So now I take my base equation, minus x minus 2y, but I'm going to substitute, equals 4. I stop and check and make sure I didn't scramble anything up. That looks good. Now I pour this into the bucket. That's the substitution. Okay, now it's just algebra. Algebra time. Minus x plus 6x, watch that minus sign, minus 16 equals 4. Same thing that we've been doing. We'll combine like terms, and then we'll swim the number over to combine the plain numbers over on that side. It's all just swimming fish, isn't it? This will be what? 5x. That cancels. 5x equals 20 once again. John comes through with a cute little number for us. He's such a pal that way. We've solved for x. Now we need to solve for y. This equation is going to help us. Y equals minus 3 times x plus 8. Substitute in the 4. Y equals minus 12 plus 8. Y equals minus 4. So our final answer is x first, then y. Yay! Have I been smiley facing these? Yes. Whew, good thing. I'd have to re-record the whole lesson if I didn't have it right. Okay, one more. Ready? John thinks he's going to play a clever little trick on us. John's kind of like our naughty little brother that whenever our friends come over, he always tries to like impress us and do little jokes and be just like an entertaining wit. Do any of you have that little brother? I kind of did. I had 2 younger brothers, so sometimes when my friends came over, they would just thrash each other and leave us alone, but other times they might try to intervene. My brothers were the kind of brothers that wrestled all the time. You know what I'm talking about? They would wake up in the morning, they would look at each other, and they would jump on each other and just start wrestling. And they would wrestle all day long, and when my mom got sick of it, she would just say, go wrestle outside. They'd wrestle all day, they'd wrestle all night, and then they'd go to bed. And then they'd get up the next day and start again. It was kind of exhausting, but I got used to it. Okay, in this one, we see, okay, look, here's our x all set up by itself. That's just what we want. There's where we can substitute it in. But it's so easy that it looks hard because x is equal to y. They're the same. So when we go, this is our base equation. So we'll write that out. 2 plus 3y equals 5. There's not like an expression to write in here. We'll just write that letter in. It's so easy, it's hard. You know what I'm saying? That happens sometimes. And then we can just combine like terms, right? And we'll get 5y equals 5. And we'll get y equals 1. That was so easy, it was almost hard. It felt like something different, didn't it? And now we have to solve for x, but look. X equals y, and y is equal to 1. So x equals 1. So our final answer is 1, 1. Huh. All right. So what we learned from these last two examples is that sometimes things might look a little weird, but don't let it throw you. Find one equation that is just a plain letter by itself, and then the equal sign, and then make the other one your base. In all 5 of these examples, John put the equation that had the plain letter on the bottom, and then he put the more complicated looking equation on the top, and we used that as our base. So that was the pattern he followed for all of these. It does not have to be that way. He was just trying to eliminate some confusion for us, and so he did it like that. But don't expect him to do it like that forever. Let me just glance at the homework. Yeah. Oh, okay. Look, look, look. Here, he does the same thing, right? There's the more complicated one. There's the x equals. But look over here. Y equals is on top, and then the more complicated one is on the bottom. Oh, he's mixing it up. And look, I made a little tiny orange mark in my book. Okay, so here is the first time I see that he mixes it up. Here's a couple more problems later in the lesson, and he goes back to the original pattern. Base equation on top, substitutable equation on the bottom, and then same over here, right? So there's the one time that he mixes it up. Remember that I want you to do all the practice and then the odds in the problem set. All the practice and the odds in the problem set. All right? If I have a student who I think is just not getting enough practice, these concepts are not settling into their brain, I will go back and ask them to do all of the problem set or maybe more of the even problems, all right? If you are diligently doing your homework on a regular basis and you're lucky enough to have a brain that is grabbing hold of these concepts, doing the odds is plenty. But I love that the evens are there so that if a student is struggling, I can give them extra practice, all right? But make sure you do all of the practices and the odd numbered problems. Okay, I can't think of a single other thing to say except, yay, substitution is fun. You will come to love it. And we're going to build a toolbox of how to solve these systems of equations. And the very first tool we're putting in is substitution. Yay, us. Okay, I'm done. Goodbye.